In the summer of 2025, the Hubble Space Telescope captured an image of an interstellar comet that should not have been physically possible, according to more than a century of established cometary science. Every comet ever observed in the history of astronomy behaves according to one basic, unbreakable rule. Sunlight and solar wind push a comet's gas and dust directly away from the sun, which is why comet tails always trail behind, pointing outward, away from our star, no matter which direction the comet itself happens to be traveling. The object astronomers had named 3I/Atlas broke that rule in plain sight, growing a bright, clearly defined jet of material pointing directly toward the sun instead, a feature astronomers call an anti-tail. Around that same time, tracking data from NASA's own Jet Propulsion Laboratory confirmed the object was accelerating in a way that could not be explained by gravity alone. Within weeks, a prominent Harvard astrophysicist was publicly suggesting the object might not be a comet at all, but something engineered. What followed was one of the most closely watched, most rigorously contested scientific debates in recent memory. And the real answer, once you separate the genuine data from the more sensational claims surrounding it, turns out to be almost as fascinating as the alternative anyone was hoping for. This is the real story of what telescopes actually detected at 3I/Atlas, and why understanding both sides of this argument matters considerably more than simply picking whichever explanation sounds more exciting. To understand why this specific object generated so much attention, you first need to understand just how rare it actually is. Objects that pass through our solar system on a hyperbolic trajectory, meaning they arrived from interstellar space and will never return once they leave, have only been confirmed 3 times in the entire history of astronomy. The first, named Oumuamua, was detected in 2017, and its unusual elongated shape sparked genuine scientific debate, including some now famous speculation from Harvard astrophysicist Avi Loeb about whether it might be artificial. The second, a genuine comet named Borisov, was detected in 2019 and behaved in ways fully consistent with ordinary cometary physics. The third, discovered on July 1st, 2025 by the Asteroid Terrestrial Impact Last Alert System Survey, was designated 3I/Atlas, and it immediately proved to be the largest, fastest, and most actively studied interstellar visitor ever recorded, observed in unprecedented detail by NASA's Hubble and James Webb Space Telescopes, the Spherix Infrared Observatory, the European Space Agency's Mars Orbiting Trace Gas Orbiter, and ground-based observatories scattered across the entire planet. The first genuinely strange observation came on July 21st, 2025, when high-resolution Hubble imaging revealed something astronomers had rarely, if ever, documented this clearly before. Rather than a conventional tail streaming away from the sun, 3I/Atlas displayed a bright, elongated feature extending in the sunward direction instead, an anti-tail, persisting through July and continuing into August. This observation was independently confirmed by multiple additional research teams and telescopes over the following months, and it was not, researchers were careful to establish, some kind of optical illusion caused by viewing geometry, the way sunward pointing tails can sometimes falsely appear due to perspective alone in certain comets. Layered on top of this visual anomaly, astronomers tracking the object's precise trajectory using NASA's JPL Horizon system detected a genuine, measurable non-gravitational acceleration, meaning the comet was deviating slightly from the path pure gravitational physics alone would predict, a deviation amounting to roughly 0.02% of the sun's own gravitational pull on the object, small in absolute terms, but clearly present and consistently measurable across multiple independent tracking efforts. It was this specific combination, an anti-tail pointing the wrong direction combined with a confirmed, unexplained acceleration, that led Avi Loeb, the same researcher who had previously raised similar questions about Oumuamua back in 2017, to begin publishing a lengthy series of papers and public essays, specifically questioning whether 3I/Atlas might be an artificial object rather than a natural comet. Over the following months, Loeb compiled and continually expanded a list of what he described as anomalies. Unusual characteristics, he argued, were individually improbable, and, taken together, statistically remarkable for a natural object. At one point, suggesting the anti-tail might represent a trailing swarm of smaller fragments rather than ordinary dust. And at another point, calculating that the comet's projected path near Jupiter in March of 2026 would bring it suspiciously close to a specific gravitational balance point, raising the speculative possibility, in his own words, that the object might be intending to release technological devices as artificial satellites of Jupiter. It is important at this point in the story to be completely direct about exactly how the broader scientific community actually responded to these specific claims, because that response was neither quiet nor ambiguous. David Jewett, a comet expert and astronomy professor at UCLA who led some of the original Hubble observations of the anti-tail, offered a considerably more grounded explanation for reporters. stating plainly that the comet is ejecting dust particles toward the Sun because the day side of its nucleus is the hot side, and that all of these observed features are entirely consistent with a comet nucleus of typical size or smaller, sublimating in sunlight and blowing dust particles outward, adding directly that there was nothing really shocking there. Jason Wright, an astronomer at Penn State University, published a detailed public rebuttal directly addressing Loeb's claims point by point, noting that similar sunward brightening effects have been documented before in other solar system comets, caused by larger, heavier dust grains that do not get swept away by solar radiation pressure and solar wind as quickly as smaller particles do on the sun-facing side of a comet's nucleus. Wright also pointed out a deeper pattern in how the debate itself had unfolded, observing that Loeb had originally argued that if the object displayed a normal cometary coma and tail as it approached the sun, that would settle the matter and confirm it as a natural comet, but that once that coma and tail actually appeared and were confirmed by multiple independent observations, Loeb shifted his position, arguing instead that a spacecraft could reasonably be expected to display those same features as well. Slava Turyshev, a longtime astrophysicist at NASA's own Jet Propulsion Laboratory, addressed the underlying physics even more directly, stating that the comet's imaging shows an entirely ordinary cometary coma and dust tail, that its orbit traces a clean hyperbola through space with no discontinuities or sudden course changes, only the small, expected non-gravitational accelerations produced by ordinary outgassing, exactly the kind of physics already used to model countless comets native to our own solar system. Turyshev was equally direct about the chemistry Webb had already detected in the comet's coma: carbon dioxide, water, carbon monoxide, ice, and dust, describing this composition as compositionally unusual compared to many solar system comets, but squarely cometary in nature and incompatible with any form of engineered hardware. He stated plainly that any measured acceleration was consistent with outgassing occurring near the comet's closest approach to the Sun, the same physics routinely applied to ordinary comets, and that nothing in the object's path, velocity, or the small residual deviations in its tracking data suggested any form of engineering whatsoever. This is not to say every scientist studying 3I/Atlas dismissed all of its unusual characteristics as completely unremarkable. Wright himself, despite firmly rejecting the artificial spacecraft hypothesis, acknowledged that a handful of the object's specific properties genuinely interested planetary scientists studying it, including an unusually high abundance of nickel detected in its coma, an extreme degree of light polarization, an unusual overall water abundance compared to its carbon dioxide content, and a notably rapid brightening following its closest solar approach. Wright's assessment of these specific properties was direct and measured, stating clearly that all of these characteristics are exactly the kind of anomalies one would reasonably expect to find in a genuinely new, previously unstudied kind of comet, originating from an entirely different star system with its own distinct formation history, and that none of them constitute actual evidence that the object is artificial, since there is no clear reason an engineered spacecraft would display any of these specific properties, while there are numerous plausible, well-understood natural explanations for why a comet formed around a different ancient star might show exactly this kind of unusual chemistry. The broader scientific and space agency community responded with similar directness. NASA itself has explicitly stated that observations confirm 3I/Atlas is genuinely active, meaning it possesses a real icy nucleus and produces an actual coma, a glowing envelope of surrounding gas and dust, precisely the physical signature that distinguishes a true comet from an asteroid or any other kind of object entirely. Researchers writing for organizations, including the BBC's Astronomy coverage, have been explicit in stating that the comet's trajectory shows no genuine sign of engineered thrust or deliberate course changes, describing its motion as governed simply by its initial interstellar velocity combined with the ordinary gravitational pull of our Sun. Mark Norris, an astronomer at the University of Lancashire, addressed the broader public conversation surrounding these claims directly, stating that despite ongoing claims that 3I/Atlas might be an alien spacecraft, a growing body of independent observations consistently reveals it to be a natural comet, not a probe originating from some distant corner of the galaxy, while acknowledging that the object does display some genuinely unusual characteristics that simply do not, on their own, prove anything artificial about its nature. It is worth pausing here to address something important about how this entire public debate actually unfolded, because it reveals something genuinely useful about how to evaluate extraordinary claims responsibly. Loeb himself, to his credit, has generally avoided stating outright that 3I/Atlas definitely is an alien spacecraft, more often framing his claims in terms of statistical probability and raising questions he argues deserve further investigation rather than issuing firm declarations. But several media outlets covering his claims took that more cautious, probability-based framing and, in the process of reporting on it, transformed it into far more sensational, definitive-sounding headlines than the underlying claims actually supported. A pattern that generated considerable frustration among other researchers, who felt the resulting public conversation had drifted substantially further from the actual evidence than responsible science reporting should ever allow. So what does the actual physics tell us, once you set aside the more speculative framing entirely and focus purely on what instruments have genuinely measured? The anti-tail phenomenon, while considerably less common than an ordinary tail, is not unprecedented among solar system comets, and researchers have identified plausible physical mechanisms capable of producing it entirely through natural processes, larger, heavier dust grains ejected from the sun facing side of a comet's nucleus that simply do not get swept away by solar radiation pressure and solar wind as quickly as the smaller, lighter particles that form a conventional tail. The measured, non-gravitational acceleration, while genuinely real and precisely documented, falls within the range routinely observed and successfully modeled in ordinary solar system comets experiencing outgassing, the same basic rocket-like effect produced whenever a comet's surface ice sublimates unevenly as it warms near the sun. And the specific chemical peculiarities Webb detected, the unusual nickel abundance, the distinct water to carbon dioxide ratio, are precisely the kind of variation scientists would genuinely expect to find in a comet that formed billions of years ago around an entirely different star, under different conditions, with a different available mix of raw chemical ingredients than anything native to our own solar system. None of this means 3i/Atlas is somehow boring or scientifically unremarkable. Quite the opposite. It represents a genuinely rare, scientifically invaluable opportunity, a direct physical sample of material that formed around a star system other than our own, offering real, measurable evidence about chemical conditions and processes that occurred somewhere else entirely in our galaxy. Information that simply cannot be obtained through any other means currently available to astronomy. That is precisely why NASA, ESA, and observatories across the world devoted such extensive, coordinated observational resources to studying this object as thoroughly as possible during its brief passage through our solar system, not because of any serious expectation that it might be artificial, but because a genuine interstellar comet, actively venting material as it approaches our sun, is simply too rare and too scientifically valuable an opportunity to leave underexamined. Here is the honest, complete conclusion this entire episode actually supports. Telescopes did genuinely detect something that initially appeared to violate a long-standing rule of cometary behavior, an anti-tail pointing directly at the sun paired with a real, measurable, unexplained acceleration. That part of the story is entirely true, extensively documented, and independently confirmed by multiple observatories and research teams. What is equally true, and equally important to report with the same directness, is that the overwhelming majority of the scientists who have actually studied this data in detail, including experts specifically focused on cometary physics at UCLA, Penn State, and NASA's own Jet Propulsion Laboratory, have concluded that every one of these observations fits comfortably within the known, well-established physics of comet behavior, once you account for the genuinely unusual, but entirely natural, composition and structure of a comet that formed around a star system considerably different from our own. The extraordinary claim requires extraordinary evidence, and while the observations here are genuinely extraordinary in their rarity and scientific value, the specific evidence needed to support an artificial origin simply has not materialized despite months of intense, dedicated observation by some of the most sophisticated instruments ever built. 3i/Atlas has already begun its final departure from our solar system, continuing on its one-way journey back out into interstellar space, never to return. What it leaves behind is not proof of alien engineering, but something scientists consider considerably more valuable in the long run. An extraordinarily rare, thoroughly documented natural sample of cosmic chemistry from another corner of our galaxy, providing genuine insight into how comets form and evolve under conditions completely different from anything found in our own solar system. If you want to see what scientists ultimately conclude as the remaining data from this object continues to be analyzed in the months ahead, subscribe and turn on notifications, because this debate, however it settles, has already taught researchers something genuinely new about how much variety exists among comets scattered throughout our galaxy.